last and final lecture of this course, which is named chemistry, and the code for this particular course is CH101 for the odd semester and CH201 for the even semester, right? Now this is the very last lecture of this particular course, and this is lecture number 35 now. What we people have been doing in this particular lecture, we'll have a recapitulation of all the things that we have present, because this is the full and final lecture, but that we'll do at the end. But before that, let us discuss what the lecture topic is and how we are going to deal with this particular lecture. Okay, so as you know, this is module 5, that is spectroscopic techniques, and we have already completed part 1 and part 2. This is the full and final part, that is part 3. And in the part 1 and part 2, we have come across two different types of spectral systems. One is the IR and another is the UV visible spectroscopy. Sorry. So in this particular lecture, we are going to see some new thing, new to you, not to me, right? This particular new thing is nothing but NMR spectroscopy. So let us start the lecture. And as you can see, this is the spectroscopic techniques in chemistry, part 3. Welcome to this particular lecture. And the topic that we people are having today is nothing but nuclear magnetic resonance. In short, NMR, right? Now, how many of you have heard about MRI scan? Tell me, how many of you have heard about MRI scan? I think many. MRI means magnetic resonance imaging, right? Now in MRI, what happens basically? A body, preferably a human body, is kept inside a huge magnet which applies magnetic field. That particular magnetic radiations actually determines whether the body is working or not, whether all the functions are good or not, whether there is any problem or not in the body, right? That is nothing but MRI. Now, if we do MRI scan of the atoms and molecules, then the process is called nuclear magnetic resonance. Okay. So, what is the principle behind this particular phenomena? The principle is, the theory behind NMR comes from the spin of the nucleus and its generated magnetic field. Without an external field, the nuclear spins are under random direction, but in presence of external field, what will happen? They will orient themselves in such a way so as to maintain the magnetic behavior. Okay. So in absence of field, this will be the orientation. In presence of field, this will be the orientation. Okay, right? Now, many atomic nuclei have a mechanical spin and angular momentum. The single angular momentum of the nucleus depends on the spin quantum number. We have discussed already. Total value will be always equal to 1, that is half plus half. A nucleus with odd number of spin mass has this property of spin. Okay, so what is the theory behind this particular topic? The NMR mostly consults with the nuclear spin. Fine, the proton is basically used for NMR, and according to the quantum mechanics, 2I plus 1 is the 2 spin range, plus half and minus half. Okay, so I don't know whether you people know quantum mechanics or not, because quantum mechanics is a devil, very complicated. Okay. Now this is the another slide that we people are having, and let us see what we are having in this slide. So NMR requires a strong magnetic field and radio wave energy. Stronger the magnetic field, greater with the energy gap, and what will happen? Better NMR will get. Okay, so this is a schematic diagram of NMR test, and how many types of nuclei present in a particular compound, that we can determine using NMR spectroscope. Basically, what happens? Suppose different type of hydrogens are present. Why? By what? By different type of hydrogens. What I mean to say, the different atmosphere. Okay, if different atmosphere of hydrogens are present, then they will give different peaks and different data. So depending on that particular thing, we can easily predict what the structure of molecule is. Basically, this used to determine the structure of the molecule. Okay. The position of the signals in the spectrum help us to know the nature of protons, aromatically, fatigue, etc. For each of these type of protons will have different electronic environment, and they will absorb at different applied field strength. Okay, so different environment will be there, different peaks will be there, right? And that we will examine to get our result. When a molecule is placed In a magnetic field, its electrons are caused due to circulate. They produce secondary magnetic moment. Okay. Induced magnetic field, rotation of these electrons about the nuclei generates a field that opposes and reinforces the applied field by the protons. Okay, so what it is saying, whenever a molecule will be placed in a magnetic field, then what will happen? Another magnetic field will be generated by the atom itself, right? And that particular magnetic field will oppose the proton's field. Thus, it will be shielded, reinforces the applied field. The proton has a higher field strength, and it will be then de-shielded. Shielding effects, absorption. Okay, fine. They've written very confused sentence. Basically, what happens whenever there is a huge magnet coming up, then what will happen? Everything will fail. So basically, when the magnet comes up, then it gets shielded. Otherwise, it can perform some function. Okay. Now, such shifts in the position of the absorption is basically called chemical shift. This is very important term for us, that is chemical shift, and we'll come across with this chemical shift later on. Okay. So whatever I have told you, that chemical shift has come up into being. The separation of resonance frequencies of nuclei in different structural environment is called chemical shift, right? Now this is very important for us. Why it is important? Because this particular shift, whatever it is happening, it will only happen under certain conditions, and there will be what I can say, a scale required, right? And that scale, or the what I can say, predictor, is TMS. Now TMS is tetramethylsilane. This particular TMS, it is tetramethylsilane, and it has almost stable value, that is 0 for this particular spectrum, right? And it gives a very high peak, because tetramethylsilane means SiCH3 whole 4. So all 12 hydrogen atoms are together suffering from the same type of field. So its chemical shift is quite good, its intensity is quite good, and it results as the base. Okay. Otherwise, all other things will come up like this. They will keep peak like this. Okay. Right. Nuclear magnetic resonance spectroscopy is a non-destructive analytical technique used to prove the nature and characteristic of molecular structure. Type of atoms present will be find out. Relative atoms present in the sample, specific environment, purity, structural information, all can be obtained from this chemical shift data. Okay. So it is written, chemistry is life. How many of you agree to this? Tell me, what is the first job that you do whenever you get up from the bed? What is the first job? I think you will say, I brush my teeth. Now you brush your teeth, like, now we have already seen the bristles, they are made up of rayon, right? Bristles are made up of rayon, that we have seen. So you are taking polymers, you are taking plastic, and on that you are taking another chemical, which is nothing but toothpaste. Now all these three chemicals are inserted into your mouth, where they will strike against your teeth. Now this teeth is again calcium, so again chemical. So the very first work that we do in our day, starting in our day, that is, we rub one chemical over the other. So you can easily predict what the importance of chemistry is in our life. We cannot move one step ahead without chemistry. Yes, you may think that I hate chemistry, fine, that is okay, but in terms of use, you have to admit that it has diversified uses. Okay, that's why I've written chemistry is life, because whatever things are going on, whatever medicines we are eating, whatever situations we are facing, whatever thing is happening, everything almost is due to chemistry. Okay, you may say this is biology, but biology is the broad thing, chemistry is the inner thing. Okay, right? So this was all about the lecture today, that is of the NMR spectrum, and let us have a quick recap of the full course chemistry, lecture number 1 to lecture number 35, so that we can have a little bit data, and we can have a quick recapitulation of the things that we people have done in this particular course in this span of lecture of 35. Okay, right? So let us have a quick recap about this. The first thing was inorganic chemistry. We started the inorganic chemistry module with chapter 1 and 1, 2, 3, 4. 4 chapters were there. right? And in that particular module, we people have clearly understood that how atoms and molecules were discovered, how different type of models are evaluated, how different types of postulates are given. All the things we have practiced, along with uh, quantum number and several other laws also we people have studied and examined. Okay. Now after this particular 4 lectures, we started the periodic table. Now in that particular thing also, different scientists like Doberner, Newland, etc., they have given their own laws, but whatever is the most possible or the best law, we have incorporated that as the law of the modern periodic table. Okay. Now what we people have seen, that basically in this periodic table term, right, we have seen the periodic properties also, that whenever we are moving from left to right, what changes in atomic structure we can see. Whenever we are going from top to bottom, what changes in ionization enthalpy we can see. That things we have studied. Okay, so this was all about the inorganic chemistry part with 8 lectures, right? Now this was followed by physical chemistry, where we have basically 2 chapters, again 8 lectures. Okay, now these 2 chapters are actually consisting of 6 lectures plus 2 lectures. Now this particular 6 lectures are supposed to be for the thermodynamics and electrochemistry, which is combinedly known as use of free energy and chemical equilibria, and the last 2 lectures are for the real gases, that is deviation from kinetic theory gas and deviation from ideal behavior of gases. Okay, so 8 lectures were present in the physical chemistry part. After that we have started organic chemistry in the third part, and we have seen 8 chapters, again 4 chapters for the stereochemistry part, where the conformation and structure and everything has been discussed, and the next 4 are the reactions, where first of all the stability was discussed, then after stability carbocation and carbanion were discussed, and after that several type of reactions were discussed, which are nothing but substitution, elimination, addition, oxidation and reduction reactions. Okay, this was all about the module number 1, 2 and 3. Now next we started module number 4, that is industrial chemistry, and started with water, right? Because water is also life, like chemistry. Water is also a chemical, right? So we started with water, we gone with 2 lectures with water, then we started corrosion. Okay, again we have 2 lectures with corrosion, we studied that, and this was followed by polymers with 3 lectures, right? That also we have studied, and furthermore one drugs chapter was there, that also we have studied, along with beautiful data about COVID-19, which is very important at this situation, right? Now after this total 4 modules, we have come across the 5th and final module, which is spectroscopic analysis, in which we are stuck right now, in which we are working right now. So there are 3 lectures, part 1, part 2 and part 3. Part 1 and part 2 had already been completed with IR spectra and UV visible spectra, and this is part 3, that is NMR spectra, which people have examined clearly, right? So this was all for the lecture and for the course CH101 for odd semester and CH201 for even semester, that is chemistry for BTech first year syllabus, right? So let us hope for a great future for you people. Have a blast in the exam, right? And whenever you are facing any problem, just jot down the problems, consult with me, and we will just sort it out, and no problems will be existing there. Okay, right? So that's all for the course chemistry for BTech first year. This is your teacher G Chakraborty from Department of Chemistry, signing off.